solving systems of equations. Today we're going to talk about solving a system of equations. We're going to use Desmos to help us solve these systems of equations, but we're going to look at some parts of it by hand. All right. One thing we're going to make sure of is that when I have a system of equations, if I have one that says y equals 3x minus 2, and the other one is y equals 1/2 x plus 3, notice that these are both equal to y. All right. From here, these are both linear. All right. I can type y equals 3x minus 2 into the first line, y equals 1/2 x plus 3 into the second line, and we'll realize that my solution is x equals 2, and here that is in Desmos. First equation is y equals 3x minus 2. Second equation is y equals 1/2 x plus 3. Notice there's one intersection of my two linear equations, and x equals 2. For my next example, we have 3x plus 2y equals 16, and we have 7x plus y equals 19. Now, notice the difference between this one and the problem we just did. The problem we did before, they were written as y equals. They were written as an equation that I would put into Desmos or a calculator. So we need to make sure that we solve both of these for y. All right, so let's start with the top one. I need to get y by itself, which means this 3x needs to go from the left side to the right side, and then I have to get rid of that 2. So I'm going to subtract 3x from both sides, minus 3x from both sides. All right, now I have 2y equals negative 3x plus 16. All right, notice the y isn't by itself yet, so I'm going to divide by 2. If I divide the left side by 2, I'm going to divide both of these terms by 2. And so that gives me negative 3 over 2 and then 16 divided by 2. So once I simplify this part, that will give me what my new equation looks like. All right, so that divides to 1, so I have y equals negative 3/2 stays negative 3/2 x, and then 16 over 2 is 8, so this is plus 8. So this is my first equation. Now for the second one, it's only 2 steps, or 1 step for that matter. I can subtract both sides by 7x, subtract both sides by 7x, and that gives me y equals negative 7x plus 19. Notice now this is written as y equals mx plus b, or slope-intercept form, so these are both linear. I can type this in the line 1, this in the line 2, or it doesn't really matter which line you type them into, but I can type them in and I'll find out that my x value is 2, and here that is on Desmos. All right, we got y equals negative 3 over 2 x plus 8, and then we have y equals negative 7x plus 19. Notice they intersect at one point, and that one point is 2. Did you know that 10 to 20% of all power outages are caused by squirrels? For the last example of solving system equations, we're going to look at one that is y equals the square root of x minus 1 and y equals x minus 7. Now, whenever I'm doing a system of equations, I don't want to do a system of equations dealing with a quadratic, or not a quadratic, sorry. I don't want to do a system of equations dealing with a radical, and that is, in this case, is going to generate a quadratic. So, if they both equal y, I can set them equal to each other. X minus 1 equals x minus 7. And now you'll recognize that this looks like when I was solving radical equations, all right? I need to rewrite this so that this radical is gone, all right? The way that I do this is I'm going to square both sides. So the square of the square root of x minus 1 and then x minus 7 squared. So what that gives me is x minus 1 equals x minus 7 squared. Now, this is something I can type in the Desmos and solve. So I'm going to do y equals x minus 1, and y equals parentheses x minus 7 squared. Now the reason is that since this is a quadratic, I'm going to have two answers. All right, and I found out that x equals 5 and 10, and here that is on Desmos. For the last example, we're typing in y equals x minus 1, and that is linear, and then y equals parentheses x minus 7 parentheses squared, that is quadratic. That means that I will have two solutions. I have x equals 5 and x equals 10.